Hi, my name is Tanu. I'm an architect at Capital One, and today I'm here to talk about DevOps and resiliency. And the reason I'm talking about it is because failure sucks. Anybody ever fail in production? Yeah, super fun. So resiliency, simply put, is the ability to recover and adapt from failure. It sounds nice, but it's a lot harder to achieve. We do have technologies that allow us to achieve them, but what I came to the realization is that the principles of DevOps, such as collaboration, allow us to achieve resiliency in a better way. So some notable characteristics of resilient systems is they can be adaptive and self-heal, usually using automation, but most importantly, they need to be predictable. If you can predict your system's behavior and you know their failure points, then you can actually implement the requirements of automation in order to respond to those failure points. So continuous monitoring is also very important, but there's a lot more to it than just throwing up a simple monitoring tool. And the way DevOps can enable resiliency is it promotes, obviously, as you know, continuous integration. So an example of that is you can use resiliency testing to inject faults, which then trigger your continuous monitoring alerts, which then drive your incident response and your automated recovery. But that's just one example, and it's just one way to do it. This resiliency framework overall gives you a holistic approach to figure out all the different failure points of your system and how to actually proactively respond to them in a way that's meaningful for your system. The first step is detection. And the major point I want to make here is we all take certain things for granted, whether that be cloud services that we're using for our system, or maybe even the standard operating procedure that we're using to operate that system. So if we use DevOps to break silos, very common point, what I'm saying here is break the silos not just between dev and operations, but also break the silos between infrastructure and applications. And that allows us to better detect failures and limits of our dependencies. For example, what's our DNS limit? What's your network limits? What's your service limits? If you don't know these things, then this is your homework assignment to go figure them out, because I guarantee you, you'll have a failure with them at some point. Next step is to alert with the DevOps mindset. So all these monitoring tools are wonderful, but they give us so much data that we need to incrementally improve how we respond. So what I'm talking about here is intelligent alerting, filtering out the noise. And if we can do that successfully, then we can actually leverage distributed tracing throughout our application stack to be able to correlate events between infrastructure and application. So again, using that DevOps mantra of breaking the silos. We then respond and recover. So now we've been able to detect an event, we've been able to alert on an event, we now need to know what to do. So what do we do based on that alert? We respond to it, so for example, autoscale, and we recover from it. For example, restoring to our previous state. Now, software-defined operations, which is a tenet of DevOps, helps us do that, right? Because we have to automate all this at the end of the day. So everything is code, infrastructure is code, even software-defined runbooks as code is important. We have rules that define how we respond to these events. But it's not a one-size-fits-all solution. We need to understand the criticality of our applications and the business factors such as RTOs and SLAs to understand our failover strategy. For example, are you going to do active-active, active-passive? It just depends. And once we know that, we can refine and test our approaches. So DevOps is all about, I think the gentleman mentioned Kaizen, which I'll steal for a second, for incremental improvements. So if we look at the different stages of DevOps, look at them with a resiliency mindset. So source code management, these are typical best practices to avoid man-made failure. But they're also dependencies. Where is your source code when you need to autoscale? Where's your configuration file when you need to bootstrap your system? Continuous integration and testing, we can incorporate things like the testing pyramid, which is already well known for quality code, but you can also incorporate ethical hacking to find your security vulnerabilities and chaos engineering testing to figure out what happens if your infrastructure fails. When you do CD, you're making very important decisions on how you deploy to different environments. From a resiliency perspective, think about your dependencies there too. So where are you retrieving your secrets from? Where are you hosting your configuration data? Last but not least, when you're orchestrating anything, and a pipeline comes to mind here for CI and CD, you need to think about what is your continuous monitoring strategy. As I mentioned before, you want to be able to filter out the noise in order to respond to only certain events. So at the end of the day, failure will happen, but use DevOps to mitigate it, so hopefully we can all live happier lives. Thank you.